G'day. This is just a quick video in response to a question that was posted on a particular version of this cube. It's going back to version 1.3 that's posted, which was sort of a transitional design. It was the last version I had with this gearbox core. So it's a version that's asymmetrical, so basically the three gears that turn remain in one half of the core, and then the other one comes out to this point and turns. So just wanted to do a quick assembly video because it was something I never got to. I quickly moved on to the latest sort of series of designs which abandoned this whole gearbox idea. Video coming shortly on that. I'm just waiting for the paint to dry on this one so I can sand it back properly. So it's just give a quick preview here. Anyone looking to print this, I'd recommend going with the later deconstructed version. And yeah, so video coming shortly on that one. Right, so back to the version 1.3. So we've got the core piece, so we print that off. We've got this little tool just to check our clearances. So you see I've inserted a spring into this one that gives it a little bit of a pop to open. But we just need to make sure that that key fits in the keyhole and turns freely, and we can get it out again because that shape there is the same geometry that's on the dials that interface with that core. So we just need to make sure that both sides fit properly. Just get our spring in the center, and we'll look for the half that has the longer protruding teeth. That's going to go in this end of the core and right in that track. Now the trick I've found is to sort of twist the core sort of on its or around its axis, and that forces those fingers apart to get them in. So sort of put it in on an angle and then just sort of spiral it in. And this is the slightly violent part because we actually have to stretch these fingers out and deform them in order to force that core in. It's one of the things I didn't like about this design that I've moved away from. So yeah, so we'll just sort of pry those fingers apart and then sort of work the core in, and once it's in we'll see how that moves. So we've got a nice smooth turning action, and then as the teeth align with the vertical tracks they can move up and down. So that's how that half rides on the core. And we'll see, this was a failed print for a number of reasons, but one in particular, we've got some under extrusion, so these fingers might just break off on me here in a second, but we'll see. So another thing worth mentioning, the whole idea of this this core is this little planetary gearbox, and as it turns, these teeth turn at different rates, and that's what locks the box. So it's sort of, you sort of have to keep turning the dial, and yeah, eventually accidentally open the box. Sort of the way this one works. The latest version is a bit more deliberate. Okay, so for the second half, we'll just get that lined up. So we'll put the core in, the gears are lined up. So now we just need to put that on there, and again we can use sort of a sort of twisting motion to just work that down. Now there we go, we've broken our finger off. So we'll just continue twisting. Oh, there we go. And that's assembled. So to lock the box, we turn the dials, and now it's locked. Okay, so we notice when we line up the gears it pops open by a couple of millimeters, and then we've got to disengage that secondary lock, which is where this key comes into play. So it won't come out at the extremities. You've got to sort of turn it to the middle before those will disengage, and it can be a bit of a knack to get it to disengage from both sides simultaneously. So I usually just cheat and reach in there with something just to pop that down and get the dial. I have to stop the gears turning. This is a bit of a pain. You can see why I moved on from this design. Yeah, so that's how we open it.